Welcome back. In the previous section, we completed the Python installation. In this video, we are going to learn the basic data types in Python. So, let's get started. Here is a list of basic data types in Python. I am assuming that you already understand the meaning of these types. However, I want to highlight two critical points about Python data types and variables. Everything is an object in Python programming. So, all these data types are actually predefined classes. While creating the Python variable, we do not specify the data type of the variable. Python will automatically infer the data type of the variable looking at the value of the variable. Great. Now let's look at some examples of Python types. Bool is to store Boolean values that are true or false. In this example, A is a Boolean type. How do I know it? I know because the expression 10 greater than 9 is a logical expression which returns a Boolean value. If you are not sure and want to check the type of an object, you can use the type function. Then you have int, which you can use to store integer values. For decimals or floating point numbers, you have float. You can use str to store text values, which should be enclosed in a single quote or a double quote. The next set is for some advanced types which can be further categorized into three groups: sequence types, set types, and mapping types. We have four main sequence types: list, tuple, range, and str. Yes, str is a sequence type. Then you have two main set types: set and frozen set. And just one mapping type, dict, commonly known as dictionary. Let us see how each one of these data types look like. This is a list. Next, we have a tuple. This is an example of range. Here, X is a str object. I will talk a little more about these sequence types and also cover how they differ. But for now, let's move on to the set types. Here is an example of set. Now this is an example of frozen set. Finally, here is an example of dictionary. We are going to cover all these advanced types in more detail, so don't worry too much about these types at this stage. You will learn more about these types as we progress with the course and start writing some code. For now, make yourself familiar with the name and the notation for representing these types. I mean, try to understand how you can represent a list like this, and this is how you can represent a tuple. Here is an example to represent a dictionary. Great. Now you know the data types. Let me talk a little about the Python variables. So in Python, you will create a variable name and assign some value to it. you do not need to specify the type. Why? Because a Python variable name is just a name that points to some object, and it can point to anything. So when we create a variable, we create a name. When we defined a text string, we created a str object. And when we assigned the str object to the variable name, the variable started pointing to the object. Each Python object contains a bunch of information, which also includes the following: a unique object ID, which is also the address of the object, a type of the object, the value of the object, and a reference count of the object. So a Python variable name is just a name that does not have a type. It only points to some object, and the type of the object is stored in the object itself, which cannot be changed. Hence, Python is a strongly typed language, which means the type of an object cannot be changed because it is part of its definition. Python determines the type of the object at runtime while performing an operation with the object. And that is how it is a dynamically typed language. Great. The next thing is the variable naming rules. Like all other languages, Python also imposes some rules for creating variable names. Here are they. You can use only the following characters: lowercase letters, uppercase letters, digits, and underscore. Variable names are case sensitive, which means this, and this one are all different names. A name must begin with a letter or an underscore, but not a digit. See, it gives me an error. Names that begin with an underscore are treated specially, which you will learn later. You cannot use Python's reserved keyword, and you can find the list of reserved keywords by executing the following line of code. You can see the full list of Python keywords. I want to highlight one more important thing about the Python types: mutability. Some Python types are mutable, but most of them are immutable. What does it mean? It means you cannot change the value of an immutable object. Once defined, they are constant and do not change. However, this mutability doesn't pose difficulty while coding. Let me explain it with a simple example. So, Python int is an immutable type. Let me define an int. So the 8-digit integer number is an object. The type of the object is int, right? The variable x is a name, and the x points to the int object. Since we have only one variable name pointing to the object, the reference count should be 1. Make sense? Let me check. Well, it shows a higher number because a few other things are going inside the Python, and reference count calculation is a complicated thing. But let's start with this number as the initial reference count. Now let's assign x to the y and check the reference count once again. What happened internally? Now the y also points to the same integer object, so the reference count of the object will increase. The variable name x and y both are pointing to the same object, which is immutable. That means you cannot change the value of the object to something else. You can try it though. Let me set some new value to the x. Do you think the value of the earlier object is changed? No. The earlier object is still the same. When you assigned a new value to x, you created a new integer object with a new value, and x started pointing to the new value. However, y is still pointing to the same old value. The reference count to the old object is now reduced. Make sense? Python is designed smartly to make the immutability an internal thing, and most of the programmers don't even realize it. One last thing. When the reference count of an object becomes 0, the object is no longer needed, and it is ready to be garbage collected by the Python garbage collection. Great, that's all for this lecture. See you in the next lecture. Keep learning and keep growing.